Hello folks, and welcome to Mears Lab. Today on the bench I have a Suzuki System 100 Omnichord. Cool. So what does this thing do? Well, this is a musical instrument, and how it works is you have this area right here and you run your fingers across it while you hold down one of these buttons over here, and it makes sound. It kind of sounds like an electronic harp. So the buttons over here are, if you're familiar with an accordion, you'll know how these work. There is this row, or the major keys, this is the minor keys, and this is the seventh keys right here. So these would be chords. So what the columns are the different chords along here. See, these are C chords, G chords, A, E, so on and so forth. So how it works is if you want to strum a C chord, you hold down C, and then you strum across here. Same if you want to play a C minor, you hold down that C on the second row, and a seventh chord. However, as you might have noticed while I strum on this, even if it's turned on, we don't hear any sound out of it. That's because there's an issue with it. Of course there is. That's why you're here, and that's why we're watching this video, and that's why I made this video. It's because I love this stuff. I love talking about it. I love teaching it, and hopefully the stuff I've learned over the years can help you out in the future in your own endeavors. So what's the problem? Well, the problem is that it just simply doesn't turn on. So I asked my client, I said, well, what's the story, like how long have you had it and when did it work last and that sort of stuff. Always important information. You want to find out as much backstory as possible, because that is how we arrive at logical conclusions. We do not make assumptions here when we're fixing things. We arrive at logical conclusions. So what the client said was that they bought it only about a month ago. Found that pretty odd, because this to me is pretty old. If I had to make a guess, this is probably from the early 90s. So jeepers, that's like almost 30 years ago now. Wow, that's nuts, crazy. Anyways, so but when they first got it, it did work. So I thought, well, that's kind of odd, weird. Okay, you only bought it a month ago and now it doesn't work. It's worked for the past 20 odd years. What's going on there? So, and then he says that a friend of his or somebody he knows replaced a resistor inside of it. And I thought, wow, well, that's odd. People don't usually say stuff like that. So what was his buddy doing, changing a resistor in here? And what is up with that? Maybe a fuse. If it had a fuse, I could see that, or something, but not a resistor. What is up with that? Anyway, so there's the clue right there. That gives us something to start with, that it did work, and then it stopped working. His buddy replaced a resistor, and it didn't seem to help with anything at all. So here is what's going on. So you'll notice that there's some stuff missing off the top of it. It's not missing all those parts. I kind of already have this thing apart, and to be perfectly honest, I've actually already repaired it. But it was such a cool repair, and there's other videos up there where, I watched one and a guy was trying to figure out how to fix this, and he didn't actually, as far as I can tell, couldn't arrive at the conclusion of how to fix it. And I have another one of these in my barn, which is broken the same way, which needs to be repaired. And I've read on the forums about people having issues with these, and it all seems to be the same thing. It just doesn't turn on. So I wonder if this is a similar issue that affects multiple Omnichords. So hopefully it does. Hopefully this gets out there and can help somebody. Anyways, yeah, so let's just flip it over here, and then we can have a look at the backside. I'm just going to hold the boards while I flip it over so they don't flop out. Here we go. And there is the backside. You can see, of course, I've already removed the back of it. Not many screws, maybe about 6 of them or so. And you always just put the screws inside of a little cup or something like that so that they don't get lost. So what are we looking at over here? Well, let's dig in and have a look. I'll grab my little pointer right here. So power comes in over here. There's a DC input jack here, and this requires an input voltage of 12 volts. And although it doesn't say in the manual that I could find or on the unit what the current rating is, I was able to deduce that it requires about 250 milliamps. And a quick Google search led me to believe that power supplies out there are usually around 500 milliamps, which to me adds up. So you know what? If you supply this with a 12 volt, 500 milliamp DC power supply, it's probably just fine. Now, something weird is this, when they bought it, it didn't come with this power supply right here. So they had to buy it themselves. I'm not sure how they did find it. They probably like went on Amazon and searched for Omnichord power supply, and then this popped up, and then they bought it. And you know what? I bet that happens all the time, and it's kind of a bit of a shame. Because you know what? I think that a lot of the time when people do that, they get the wrong power supply, and that's exactly what happened in this case. This is not the right power supply for it. But we can fix it, yeah. And this is why it's not right. So let's look at it here. So on here, I hope you guys can read all this. Here we go. So on here it says 12 volt DC output. Awesome, that's what we want to see. 500 milliamps. Yeah, I totally want to see that. But you know what? This is where the problem happens right here. Is this little symbol down here. This has to do with the polarity of the tip, because the tip of this power supply, let's see if we can get that up here. Let's see if we can get it to focus even too. So if we look at this tip, there's the sleeve, of course, which is the part on the outside. There's the part on the inside, and that's the what supplies the voltage. In most core cases, this will be like your common or ground or whatever, and this is where the actual voltage is on the inside of it. Now this one, when it has like a little C shape on here and a dot in the middle, and whatever the dot is in the middle, that is the tip, and then the C shape on the outside, that's the sleeve. So that's the outside part of the plug here. Or once again, this is the sleeve, and this is the tip right here on the inside. So on this one, you can see there's a positive sign right beside the tip, and there's a negative sign beside the sleeve. So that means that this is a positive tip power supply. That means that the tip is plus 12 volts, and if the referenced to the sleeve, which would be, well, 0 volts, we'll say. So you can get these in a negative tip supply as well too, and it just means that the positive is over here and the negative is over here. And when you read it, if you put your negative probe right here with your multimeter and your positive probe there, it's actually going to read negative 12 volts. And some circuits require that, and this is one of them right here. This one does need that kind of power supply. So this one, as it is not going to work, and is probably the reason why they had to replace a resistor on it as well. See, I love the whole logical conclusions electronics idea because it's fascinating. It's cool because it's all problem solving, you know? You figure it all out in your head and you're like, yeah, this is probably how the whole problem happened, because sometimes there's just no way to know, and sometimes however it broke, people don't even know how it broke, you know? But you can figure it out yourself. It's so cool. Anyways, so we're going to modify this so that it will work with this, because currently it's not. So here's the issue. Okay, first of all, the guy didn't say where the resistor was that they replaced, but I was able to figure it out on my own. So I started with the power kind of input board over here. And the way that the circuitry works, there is a, well, I suppose, you know, if you were so inclined, you could go and find this schematic online here. This is actually for a, so might as well zoom all the way in here. Let's get right in there. So this one is actually for an OM100 and a 200M, and you can see the revisions for the 200M are these spots that are right here with the dotted lines around them. There's one there and over here. Anyways, whatever. That's not important to what we're talking about right now. Let's zoom out a little bit more here so we can see that a bit better. Okay, so what's happening is we can read the schematic, and that kind of explains, you know, what does what on here, but we can also just kind of look at it and figure it out pretty quickly ourselves. So let's zoom out. Over here, that's where the power simply comes in, a little bit of filtering from this capacitor right here. Then it's going to go over to this board, and through these connectors, this is a little tricky on this one. You actually have to remove this board to see all this, and I can't take it out now because everything's all plugged in. But the power goes over here, and then goes through some stuff here, and then it kind of goes through a bunch of stuff over here, and then this is the power amplifier chip right here, this TA7222AP, and then it goes from there to the speaker, and that's what happens. So if you put power in here and you turn the switch on, the lights don't turn on, you don't hear anything, nothing at all. But the weird thing was, I could still read voltages on here. So when I took my multimeter and I probed like this 7805 right over here, and there should be like a 12 volt on one of these pins and a 5 volt in the other, and maybe something else on one of the other ones, but all of them are reading 12 volts, and I thought, that is so weird, like that maybe that's bad or something. So I took it out, tested it, and it's fine. So put it back in. And, you know, and it's just like, there's like 12 volts all over this thing. And I couldn't figure it out, right? Because I tried to turn it on. The lights don't turn on. It doesn't turn on, but I can read 12 volts everywhere. So I figured, that's weird, man. Like, why is it that I can read voltage, but like, it's not turning on? So what I did next is I got a current reading. I used my power supply, plugged it in here, put my multimeter in line. And there's a careful way you got to do that. I'm not going to go into it right now because that'll take too long to explain it. But I was able to measure that it was only a super duper low current. It was like 50 milliamps. And I thought, man, that's like, no, not even that, not even 50 milliamps. It was like 0.5 of a milliamp. It was like not even 1 milliamp. So what it was is a little teeny tiny bit of voltage kind of squeaking through. And my meter was able to detect that it was 12 volts, but very, 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 very low current. So there's another clue. So, you know, it was at that point that I was about ready to give up on the thing. And then I just thought, you know what, Tom? Just get back in there and have another look at this. It's probably something simple. Sometimes it is. And yeah, it was. And the problem was, as I'd kind of suggested earlier, it was this little resistor that their buddy had put into it. And here's why it was an issue. They put the wrong value in. So let's get into it here. So here's the resistor that they put in that caused an issue. So by reading this, we'll see that this is a red, orange with a gold tolerance band on it. Gold, super good tolerance band, of course. But red, orange. So red is 2, orange is 3. So this will be a 22K resistor, 22 kilo ohms. Now let's look at the schematic and see what we're supposed to be in there. So here we are. This is where the power comes in right here. There's the batteries right there, which you can't see, but the batteries normally would kind of go over here. So goes in here. There's a power switch right there, and then bam, first thing after the power switch, resistor. It's super duper hard to read on here. I know you guys probably can't even see that, but if you really want to, you can, you know, go and get your own schematic and follow along, the comfort of your own home. But anyways, what it says here is it's a 1/2 watt 2.2. And I thought, wow, either this is a typo or somebody really put the wrong resistor in there, because what was installed in that position, which is, by the way, on this board right over here, is a 22K resistor. And that would explain why I could read 12 volts in some places on the board. Pardon me. That would explain why I can read 12 volts in some places on the board, but at a super low current. So what I did was now you want to be very careful how you do this, is I took a little jumper, like this guy here, like a little alligator clip jumper, and I simply just jumped the leads. So let's flip this over and have a look at the problem area. This is where the fix occurred, and this is where the problem was, of course. So let's zoom in here. So this is where the bad, well, it was a good resistor, but this is where it was installed. So all I did is I just took that little alligator clip and I just went boop, 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 while power was applied to it very quickly, very carefully. And as soon as I did that, it turned on. So I was able to tell, well, okay, it's probably fine. It's probably that resistor. The reason why I was able to do that, of course, is because this is just a little 2.2 ohm resistor. If what is supposed to be in here was like a much higher resistance than that, then I couldn't just simply bridge it, because I would be allowing too much current to pass through the circuitry and I'd almost certainly damage it. But because it's just a low current, because it's just a low resistor value, like 2.2 ohms, I could just bridge it really quickly, and I was able to deduce that that would fix it. So I simply just removed the 22K that was installed incorrectly, put the 2.2 ohm in, and it worked perfectly. So, and of course it indicates on here it's a half watt. And to make matters worse, they actually, well, not that it would really matter with resistance this high, but this is a 1/4 watt resistor, and I put an actual half watt 2.2 in. So this is the correct resistor in here now, and that is likely the problem. So if you have one of these and it's not working correctly and you would like it to work correctly, then it's very likely this resistor. And we can get into why that is here in just a moment. Okay, we're back, and I want to explain why this is an issue, this resistor right over here that goes bad. And it's kind of fun. So this is how we're going to do it. Now remember back when I said that the current draw for this unit is about 250 milliamps? Well, that's how we're going to figure this out. Okay? So we're going to use a couple of simple equations, and this is equations like Ohm's law and how we figure out power in a circuit, and that helps us to figure out, you know, resistor values and things like that. So anyways, what we do is we take the amount of voltage that's going to be applied across the resistor, and we take the ohms reading on it, and we take the current, and we kind of add them up together and multiply them or divide them or whatever, and then that's what gives us our values. So if we took a 20, I'm pretty sure the math checks out on this one. The numbers are crazy, so, you know, if I'm wrong, please do correct me in the comments. But anyways, this is what I came up with. So if we take a 22K resistor, and let's find something to write with here. Here's this pen, and we use if we use Ohm's law, which is volts equals current times resistance, which you can remember because it's a very important rule, VIR. And then the other one is power equals voltage times current. Those are the two ones we're going to use to figure this out. Hopefully you can read that. Let's make those so that you can read them a little bit better. Yeah, that's goodness right there. Awesome. These two equations are going to get you through so much electronics, and I know a couple of more, but these are the ones I use all the time right here. They're the best. Okay, so if we want to figure out why the first one didn't work, we add in the resistance, 22,000, which would go in right here, because we're trying to figure out how much voltage it would drop, how many volts it would drop. We times it by the current, so times that by 0.25, right? 250 milliamps. We get 5,500 volts. That's how much it would drop. So yeah, obviously that's why there was like nothing squeaking through. So, but if we take a 2.2 ohm resistor and we times that by what are we at here? 250 milliamps. Then we only get about a half a volt drop, 0.55. And that would have like almost no effect on the circuitry in this. So that's definitely something cool. That's definitely what we would want. So, but this is where it gets interesting right here, because they say that it should be a half watt resistor inside that location. So this is where we need to use this equation right here and make sure that a 1/4 watt or a half watt resistor is actually okay and that it's not going to overheat and burn up. So what we do is we take the voltage, plug in 0.55 right there, which is how much voltage, how many volts are going to get dropped across the resistor, times that by the current, which is 250 milliamps. And so let's add it up here, 0.55 times 0.25 equals 0.1375. So that is not even a quarter of a watt. It's like an eighth of a watt, or a little bit more. Maybe, I don't know, probably something like that. I'm not very good at fractions. Anyways, that means that a quarter watt resistor is fine to use in that location. So a half watt resistor is going to be more than fine. So that's why they say to use a half watt in that location. However, though, if we were to go to the maximum current rating for the power supply that's recommended for this, which is 500 milliamps, that changes. So we take 0.55, put it right there, times that by 0.5, which would be 500 milliamps. Oh, look at that. That's more than a quarter watt. Oh, but over time, you see, that could potentially cause the resistor to wear out. However, for a half watt resistor, that's way underneath. Remember, a half watt resistor would be 0.5 right here. So half watt should be fine in there. I've tested it by, I don't recommend you do this at home, but I've tested it myself by just simply putting my finger on it while voltage is applied to see how hot it was, and it was just fine. So no worries there. I think that the part of the reason why it actually failed is because they plugged the wrong power supply in. What I figure probably happened was they bought the unit, they didn't have a power supply, they were just using batteries with it. They figured, oh, it would be so nice if we could just use a power supply, because the batteries are expensive and they always run out because it uses 8C batteries and they're expensive and they don't last very long in something like this, especially with that much current draw, right? 250 milliamps, not gonna last long at all. So what they did is they probably popped on the Azon place or the EA place, and then they bought a power supply for it, plugged it in, left it turned on, and it probably burned out the resistor, and that's probably what happened. So anyways, what I'm going to do the repair on this is replace the resistor. I've already done that. Then I'm going to simply just cut the tip off of this power supply, and then I'm going to reverse the leads and solder it back together, and of course put some nice heat shrink on that as well too, to make it look nice and safe to use. And then I'll spray out all the pots and clean everything on this, and then it should work really good after that. Anyways, yeah, so that's where that's what we're gonna do to fix this one, and that's really where the issue came from. It's just this little resistor over here. So hope this was able to help some of you folks at home. Thanks for tuning in. Once again, I'm Thomas. Thanks for checking out Mears Lab.